it is emphasized it's not just for right triangles, for all angles. Main motivation for entering trigonometry of all angles is the circular motion. So that was a little ancient geometry problem, architectural problem. And here we're entering more of a circular motion modern problem. Okay? And I color that, and that's 6.3 and on, and this is going to be always like this. Trigonometric functions versus trigonometric ratios, right? That's the one thing. Ratio is that ratio is important information. Therefore, for a smaller object to the larger object. But now they're entering a functions, a more modern concept of doing mathematics. So let me emphasize a little bit more about functions. I've seen this word many, many times, and here I'm trying to do this again because I know everybody understands function in a slightly different way. So here's my introduction or review. Function is the following. You're given an input. In your education, it's usually numbers, right? They give you a number. And there's an instruction. They tell you what to do with that number. Add and subtract and multiply, put a square root and divide it by all that instructions given, and then you get an output. All right? That whole concept, including the instruction, is called a function. Just like an angle. Angle is not a number, right? Is that all initial side and information? Just like that, function is not a number. It is the instruction given with the input. That's pretty much what that is. All right? And often our instruction is given by formulas with a square root symbol and exponential symbol, and that formula, the one-line formula, tells you instruction. And some of us are good and some of us are not. It's actually one box and one line information. It has the sensitive order of operation, right? Although it's written in one box, there is a parenthesis, and you have to calculate two different things at the same time, and then add it later. All that order of operation is one of the major obstacles for youngsters to look at the expression and figure out what is the order of operation, right? So many of you have forgotten about that. As soon as you have a calculator and calculator takes care of everything, then you forgot about the order of operation. But what's important in a function is that you have an input. And this instruction unfolded out of this massive expression, the order of operation and doing this, what you do with that number. And at the end, boom, you get a number. The whole thing is called function. All right? So I'd like to introduce the trigonometry function in that fashion. Especially, this order of operation you do is something you understand, addition, subtraction. And this thing we're about to do is something we do not understand. Therefore, we lose computability. We cannot do this by hand. We cannot compute it. But the picture is very precise and precisely defined. So you can kind of think of it there. I don't know where that sun is at the moment, but it's right there. There must be some number that associated from here to that distance or angle, something like that. So that distance we can think of is an instruction. Let that be whatever. So that kind of instruction is given. So that's the trigonometric functions. And let me see that what I have in the next slide. Got a little disorganized in here. So that's how we're going to understand it. And you will see that what that instruction is, right, for trigonometric functions. And this is it, the trigonometry of all angles and circular motions. And here's the word again, trigonometry functions. These are the main two applications with that extended all angle version. First one is a triangle that is not right triangle, but obtuse triangle. For that, you will learn the trigonometric laws that apply not only the right triangle, but acute triangle and obtuse triangles. The thing that you know is always about the right triangle. So for that, this turns out this all angle extension is helpful, useful. And more importantly, that this trigonometric circular motion is used in there. This, what is in the parentheses, is probably not going to be covered. It's optional for the department syllabus as well. But if we have time, we'll cover that a little bit. But this is also a very important part. Comes later in the calculus and on. All right. On Tuesday, at the beginning of class, I'll give you 2 minutes to restate what is called the definition of a trigonometric function of all angles. These are in terms of a Cartesian coordinates. Cartesian coordinates are x-coordinate and y-coordinate, namely x and y. Okay? But if you state the same old ancient definition, opposite divided by hypotenuse and things like that, what do you get? You will get 0 point for that quiz. So please clearly distinguish your understanding of a trigonometry in terms of Cartesian coordinates, not in terms of size of a triangle. All right? All you have to state will be summarized in the box I'm going to show you. All you have to state what's in the box, all right? But we'll go towards that. So if you're good at memorizing this type of stuff, you have a visual, good, photographic memory, you don't have to follow this order, but it might help you. So the first thing we're going to do is sketching this circle and state the circle equation. All right? So here is the definition. Is a label of that box, and I'm collecting things in here. I'm going to box it out. That's all you have to state in 2 minutes. So what was the first thing again? Sketch the circle. But it's not like this. It is embedded in where? XY. What is a fancy name for this plane? Cartesian coordinate plane. Descartes invented this. The mathematics changed from there on. All right, so circle, what was the one more item in that step 1? Circle equation, right? Circle equation. This circle is centered at the origin. I have to specify that. How can you write down a circle equation if you don't know the radius of this guy, right? So you have to specify the radius, like 3 or 5, but it could be anything. So letter R is usually used for arbitrary size of a circle. R cannot be negative. There's no circle of radius -5, right? So we understand whatever the circle here is, R is always a positive number. All right? I have not written down the equations yet. So, does anybody remember the circle equation centered at the origin? Equals R squared. R squared. Great. We couldn't get that one last previous hour. Great. We have someone who knows this equation. This came from distance formula. Distance from the origin to some point on that circle is supposed to be always R, right? Does not matter. That distance formula actually leads to that. The left-hand side is the square of a distance from 0, 0 to arbitrary point on the circle. Should be always R. So it's R squared. So that's the standard circle equation. Make sense? All right. That was step 1. Sketch a circle and state the circle equation. Number 2, sketch an angle with rotation indicated, and we're going to call that angle theta. I forgot to write that down. At some point, I'm going to share this slides here so that you can use your own, so you can see, kind of have a big picture of what was studied. I think is going to be useful for you. So I'll share that in our Google Drive. It'll be announced that. So let's see. All right, I'm going to sketch this. What did he say in that parenthesis? Remember what I said? Choose one out other than the first quadrant, so that you understand the circle can be anywhere. I mean, the angle can be anywhere, right? You can put your angle over here in second quadrant, third quadrant, doesn't matter. But I'm going to put that this time here in the second quadrant. So here's the terminal side. Not terminal, right? Going forever, it kind of stops somewhere in the circle. That's the terminal side. Good? But what else was there in that description? Sketch an angle with what indicated? Rotation, right? So rotation could be anything. Again, to let you kind of trigger your memory that it is an arbitrary angle, I'm going to go like this. Clockwise or counterclockwise? clockwise is negative angle, right? It could be one more rotation is involved. Things it's just an arbitrary sketch. It could be 2015 clockwise rotation. And drop it there. And you label it like a Greek letter, right? What was the Greek letter for that? Theta, right there. That is our step 2. Does that make sense? Sketch an angle with a rotation indicated and label it theta. Step 3. Label the terminal point x comma y, and it's just a comment. Keep in mind the x and y can be negative numbers because it's a coordinate. Coordinate, you have negative numbers, right? So what is this point here? X comma y. We're going to label it. And I decided to call that point P. Right? So again, what was the little comment underneath it of this step? X and y can be negative number. You're never going to change that to positive. X is negative 5. X is negative 5. Right? So that's a setup. That's how much a setup is required to define trigonometric blank. What was a blank? What we were about to define? Trigonometric functions, not ratios. All right? So this setup is there. And then I think next step is state the definition of the 3 trigonometric functions. Okay? So here it is. On that side right here, you're going to define it. So how do we define a function? You're given an input, and you understand the instruction, whether you can actually compute the things that involve in that instruction, and you understand there's supposed to be output right there. So what is your input? That input is theta. To correctly describe theta, you need this rotation and angle, right? You don't need circle just to describe theta, right? What is the instruction? To describe instruction correctly, we need circle, equation, radius, terminal point identified. That is required to describe this instruction. So go to that angle and terminal point, instruction number 1 of this function. Read off this x and y coordinate at that point. That you cannot do by hand. If I give you 170 degrees, can you go ahead and calculate that by hand? Absolutely no. But you know it's right there, right? So take that x coordinate divided by radius. That is your output. Instruction, draw a circle, look at the terminal coordinates, and x coordinate of that terminal point divided by the radius of the circle. That's my instruction. And get this output. Does it look like a function is defined for you? Whether you can compute it or not? The name of this function is cosine. Like that. We're doing cosine first because it is x coordinate. We usually talk about x coordinate first before we talk about y coordinate. It's alright? So that is our new definition. There is no adjacent or hypotenuse, but there is x coordinate and radius of the circle. That is the analogy, that is the extension of analogy. Remember that part? Alright? So the second function is about to define. You're given a theta, and you do similar instructions that you go to that function. This time y coordinate divided by radius. That's the function. What is the name of the function? Sine. That whole instruction is packed into that 3-letter sign. Alright? Third one, theta is given. You divide the y coordinate, x coordinate is there. We can't compute it. And that's called tangent. That is the end of the definition. You see this in the box. If you just restate everything that is in the box without missing anything, no arrow. If you miss arrow, points go down. If you don't label theta, points go down. If you don't label anywhere r, points go down. All of this is the least amount of information to state this one. All of it goes into your way of understanding. And being able to state help you to do things correctly as well. So that's a 2-minute work. Everything in the circle, in the box. That's all I want. Is that okay? Alright. Then you get 2 points. Unfortunately, that's not bonus. That's your part of your quiz. So quiz is a total 30 points out of 100 session grades. That 2 points that you're going to do on that Tuesday is coming from there. So your homework is total out of 28 points. Does that make sense? Yeah. But mock test I talked about is bonus. You get bonus point for doing that. All right. We'll do more about this definition using the example. But here's a summary. Sketch the circle equation. Angle indicated with label theta. Terminal point labeled like that. Identified like that with label P. And state those three trigonometric functions. But what are the other three? Secant is x over y, r over x, and things like that. That you don't have to state. But I hope you understand what those are. All right. Here's one more thing the cool thing I'd like to relate it to. X coordinate you saw is a rectangular coordinate system, right? Y coordinate, what is this M? In rectangular coordinate system, you learn about this M. What is it? Slope, right? M is the standard letter for the slope of a line, right? So those three things, basic three things that you learn in the coordinate algebra, right? What's in the right-hand side? Trigonometry, cosine and sine and tangent, right? Most natural information when you're sitting in the Earth and look around the universe is just rotate around. It's more like what is the distance r to that? How is the angle is changing? That's more relevant information, right? So that's actually have huge application in physics and engineering. Polar coordinates, center and angle and radius, that's different type of geometric information. So these two correspondence goes forever in your mathematical education career. That is always there. It's very, very important, right? This is called trigonometric parameterization of your Cartesian coordinate plane. So let me go ahead and state at this stage, this one. If you look at this coordinate equation, this is really definition, but that's how it's connected, then can you solve that for x? Yeah, what is it? Cosine times r. That's right. But they usually write r first. R there, it's a cosine theta there, like that. So if you have a Cartesian coordinate x, that's how it changes to trigonometric parameterization. Distance from where we are to that, an angle is changing. That's how you get that universal, x coordinate for God. If God is looking at from above, well, x, y plane, kind of thing. How about y? R times the sine theta. This parameterization appears forever in the mathematical and science literature. How about that one there? What was the meaning of yx? Y divided by x here. That's the point. Y divided by x. Isn't that the slope of this line? Right? That's exactly the slope of that line. So slope of the line M is a tangent theta. All right? That's what I just talked about. It's an important thing. When you're doing the homework and prepare for the test, you might use other sources. They do problem in a certain way, and it is kind of similar. Maybe they take shortcuts and everything. But I'm going to use the term circle method, and the mock test will say use the circle method, and the test problem will say use the circle method. Then you have to use the circle method, whatever that is, right? I do this forcefully like this because I believe keep repeating this tedious thing really helps you to understand sine and cosine in the right way, not ancient way, but the right triangle way, right? So until I sense that everybody's just on top of this, master this circle method, and then I stop asking you to do that. But at the moment, we'll stick to that. What is the circle method? Sketch a circle and do problems around that circle with the equation written, right? Not anything else. And if you don't use the circle method because you know how to find the answer correctly, then you're not going to get the good credit in the test. You have to show me that you understand the circle method.